All right, so today we are going to talk about containers, the concept of the software containers and containerization. Okay, so just to introduce the motivation for the concept to begin with. Now, we have some exercises. So the exercise we had the last on Monday that we created the visualization using NumPy. If we want to draw the dependency graph of that small exercise, this is how it would look like. So first of all, what is a dependency? So a dependency is something that your application depend on in order to be executed. Okay. Okay. So that might include third-party libraries. That might include the existence of particular files. Okay. So if we look at the small exercise that we had on Monday in which we created the visualization. So our script depends on MATLAB library, right? Not Matplot library to begin with. And we because we imported it, so it has to be installed. So if we took our script and run it on a different machine, is it gonna run? Well, it depends whether it has Matplotlib installed or not, right? And we also imported NumPy and pandas, right? Now the same script with all the it's not just the fact that you're importing. So we are importing something, it means that we're depending on it. So take that, your program is correct, it runs in your machine. Take that program and try to run it on another machine. Is it gonna run properly or not? Now that depends whether the library is installed with the same versions that you are using. So you can have an older version of NumPy, for example, or a newer version of NumPy, or an older or a newer version of pandas. Like it's not just that it needs to be installed and it needs to be installed with a particular version that is compatible with the code that you're using, right? So it's not only that. So your program is dependent on these libraries that the imports that we import directly, and some of these libraries depend on each other as well. So you know that pandas build on NumPy, okay, and you know that pandas also has some functionalities that build on Matplot. So if you really want to understand that dependency of the program, it can get very complicated, and that's just a very small exercise that we use. Okay, now if we want to see an example of a more realistic dependency graph, it might look like that. Obviously, you can't see anything, right? Now we can always zoom in. I mean, we can, if we have the direct image, we can try to zoom in and see it. Now you see, it is very hard to read. And when you zoom in, you can only see one part. So if you want to see the entire picture, it's still not easy. Now you see how it is difficult just to read, let alone manage. Okay, so realistic, more realistic application requires may require more complicated dependencies. Okay. And what happens when we create software, we don't create it to stay in one machine, right? We create it to be, so there is a development environment. There is at least 3 environments that our software is gonna have to move between. Okay, so there's a development environment in which we do the development, and then the production environment is the final destination, which the application is supposed to run, the final destination. Well, like if it's a web application, then it's deployed on the accessible through the web. If it's not, then it should be installed at the customer site. Okay, so the production environment is the environment in which it's supposed to run. Okay, and at least there has to be one environment. I mean, it doesn't have to, but typically in a real software house, you would have a test environment in order to test your application before you send it to production. Okay, so there could be more. There could be staging environment. There could be more than testing environment. The idea is that your software has to be moved, and this movement is typically described by the verb ship. So you need to ship your software among different environments. And it is very common problem that while you're moving software from environment to environment, you may miss one of the dependencies. You may have different versions, like some things has to fall. Like if you're moving stuff around in different times, there is a very high chance that something is going to be missing. And you get the situation that a software is running in one machine, but it's not running in another machine. So it's running in the development environment, but it's not running on the testing environment, or there's a bug that appeared suddenly in the production environment. I used to see this problem when I used to use OWL for submission for programming assignments. So oftentimes students would submit their programming or their code, but missing one file or with an older version of a file. So when we get to test it for the sake of grading, we see something that this is not what the students see. Okay, so I used to see this problem before I switched to using GitHub Classroom, but you may have experienced that as well. Okay, so just one file can break the whole thing. Okay, so that was the motivation of borrowing from the literal shipment industry. So you see that we use the word ship is in a metaphorical way. So we ship something, that means we move it from one place to another place. But there is the shipment industry, the literal shipment industry, where you actually use ships to move things, right? Had this problem as well. I have very similar problem. Before the invention of the physical containers, things that used to be shipped like in a loose way in the ships, right? So that means that they could be mixed up with other people's shipments. They could get broken, right? There's something can be lost, right? And then the concept of the physical container was introduced, and that solved a lot of the problems there. A lot of the problems in the movement of things to ship. So first of all, it has a standard size. So it was easy to design the ship itself or know exactly how much containers or how many containers it can take. Okay. And it provides an encapsulation of the shipment. Okay. So the possibility of something get mixed up with other shipments or something can get lost is not there anymore. Okay. Because inside the container, they are encapsulated. So now the concept of the software container borrows from that literal physical containers and try to use the same solution to solve the problem of moving software between environments. Okay, that explains the logo of Docker. So Docker is a company that provides tools that help with the containerization. Okay, and this is their logo. So the whale is like kind of like the ship and the containers are on top of it. Okay, so that explains the motivation or the inspiration from the literal container ship containers. And there are various different variations of the logo, okay, with different colors. It's pretty much the same concept. All right, so that's what we are trying to do. We are trying to package or encapsulate our software and all its dependencies and whatever it needs in one unit that we call the software container. Okay. Now there are four main components in the containerization system. There is the runtime engine, and then the container itself, and then there is what's called container image, and then the container image registry. Okay, we'll see these four components in a Now, let's talk about the container, the container itself, and the runtime engine. So in order to run a container, it has to run on top of a runtime engine. So if you compare that with executing regular software that is not packaged in a container, you would have to make sure that all the dependencies are installed, and then your application is installed as well. Okay? And then all of them run directly on the operating system. All right? Now, when you have containerization, you would have the container runtime engine itself as a layer that separates the container from the operating system, so that the containerized application can run on any application, any operating system. So it kind of resembles the concept of a virtual machine. And if you have experience trying to run a Windows-based application on a Mac machine, you would have to run, I mean, there are different ways. One of them is to have a Windows virtual machine, right? So now you see the concept of the runtime engineer container, the container runtime engine resembles the concept of a virtual machine a little bit. And there is an overlap between the two concepts, but a lot of people confuse the engine with a virtual machine. And the reality is that the runtime engine acts as a virtual machine a little bit, but it's much lighter. Okay, so